Hi to everyone, and thanks for joining us for the Spectro Scientific webinar. Okay, right now I'd like to introduce today's presenter, Yugung Zhao. He's the Senior Vice President of Sales and Marketing at Spectro Scientific. Mr. Zhao has over 15 years of experience in the electronics and analytical instrumentation industries. He has held positions in a variety of markets, including semiconductor, aerospace, energy, and heavy equipment maintenance for industrial manufacturers. Yugung, welcome to today's event, and with that, I'm going to pass things over to you to get us started, so go right ahead.
Hello everyone, thank you for joining us today. My name is Yugung Zhao. I'm the Senior Vice President of Sales and Marketing of Spectro Scientific. Today, I would like to introduce a new approach to on-site oil analysis for the Industrial 4.0 area, using our TruVu 360 Enterprise Fluid Intelligence platform. The agenda of the seminar is the following. First, we'll discuss briefly the new challenges introduced by the Industrial 4.0 and the need for a new approach to oil analysis for predictive maintenance for companies to stay competitive. Then, we'll introduce the TruVu 360 Enterprise Fluid Intelligence platform and its two components, the TruVu 360 Enterprise Cloud software and on-site testing system with MiniLab series hardware and TruVu 360 device console software. In the end, we'll discuss how companies can benefit from the standardization of best practices of oil analysis on a global scale. Before I start, I would like to do a quick introduction of Spectro Scientific for those who are not familiar with the company. Founded in 1983, Spectro Scientific is the world's largest turnkey on-site oil analysis provider for predictive maintenance. We serve customers over 100 countries in various industries where companies use on-site oil analysis as a critical component of predictive maintenance practices so that they can improve asset availability and reduce operation cost. Spectro Scientific is headquartered in Chelmsford, Massachusetts, in Greater Boston area, and is ISO 9001:2015 certified. So back to the agenda of this seminar. First, I would like to discuss the need for a new approach to oil analysis for predictive maintenance in the Industrial 4.0 era. I would like to talk about some microeconomic trends first. We are right in the middle of the fourth industrial revolution, or Industrial 4.0, where cloud computing, cyber-physical ecosystems like Internet of Things, and cognitive computing has fundamentally changed how manufacturing is done. To stay competitive and drive profitability or growth, companies are increasingly focused on greater asset availability and use data-based decision-making to drive more returns on assets. So what this means is that there is an increased focus on strategic asset management to maintain asset reliability and uptime, and there is more reliance on condition monitoring techniques to enable predictive maintenance so that the costly downtime can be avoided. On the other hand, aging workforce limited the availability of in-house expertise and drove companies to seek third-party solutions. There are a lot of developments on application-specific techniques to assess high-risk systems and components. And with the well-established paradigm of going mobile, there's a broad-based demand for intuitive software to simplify and automate previously complex and cumbersome processes and enable rapid, comprehensive, and actionable data for real-time decisions. One of the outcomes of Industry 4.0 is the availability of huge amount of data that was impossible to obtain before. Unfortunately, without quality, it is very easy for companies to get overwhelmed with this amount of data. It is important to note that big data does not automatically mean quality information. Actually, a recent McKinsey report looking at Internet of Things data on a drilling rig reveals that 99% of the data never left the rig platform, therefore not as valuable as it could have been. Actually, The quality of data and information is never more important today than ever, as companies are literally drawn in this data sea. In the context of quality data and actionable information, oil analysis traditionally has the reputation of providing very comprehensive and insightful information for predicting maintenance. Similar to blood test, analysis from in-service oil samples can tell if machine is healthy by looking at the wear particles in the oil, if oil is still fit for use by looking at physical and chemical properties, and if there is any external contamination of sand and dirt, water, or other foreign fluids. From oil analysis reports, actions can be recommended to maintenance team like filter or change oil, extend oil drain, or some maintenance actions on the machine. There are three main benefits of implementing oil analysis programs. First benefit is the increase of asset availability and reliability by reduction of unplanned downtime, increase in asset life, increase in asset machine utilization, and reduction of risk of catastrophic failures. Second is the reduction of operating costs from reduction of oil usage, lower maintenance cost, lower recycling cost, and a reduction in inventory. The third benefit is the improved productivity because oil analysis can help repair more timely and effectively, improve worker safety, and improve maintenance and resource productivity and utilization. There's a long history of using oil analysis for predictive maintenance. In traditional oil analysis approach, maintenance engineers collect oil samples from the machine and send them to an offsite laboratory for analysis. The process usually starts from collecting a sample, labeling the bottle, packing it, and ship it to the lab. Lab receive the sample, log this in their information management system, and perform the test, diagnose the result, and provide recommendations to their customers. The report is then received, printed, and reviewed by the maintenance team, and maintenance actions may be carried out depending on the recommendation. There are benefits definitely working with offsite laboratories. As a starter, there's no capital investment as user is only paying for a sample. The laboratory has been the industry standard for a long time, and they've been very actively promoting the benefits of oil analysis and helping educate the whole industry. On the other hand, there are some obvious limitations of this offsite approach. First of all, the cycle time is long. It can range from days to weeks, and most of the time, it is the logistic and shipping to be blamed. And it is very difficult to improve as some of the sites are just so remote in nature. And because of the long cycle time, reports tends to arrive too late in the process to be incorporated into the workflow. So decision making can't really be made based on the report. Especially if the recommendation is to take another sample and verify the issue, then it's another process and it makes the whole recommendation not very useful. The quality of the information can be in question as well because during the process there are many people involved from oil collector to shipper to a lab to maintenance crew, and there are many hands-offs. They can potentially introduce human errors on the information, and the samples can also potentially be contaminated during the process. Missing or wrong information or contaminated samples can make the test results and recommendation not very useful at all. Since the lab could be hundreds of miles away from the asset, from the maintenance crew, recommendations on maintenance actions sometimes tend to be generic in nature and not very specific to the actual situation. So when a maintenance crew sees those kind of recommendations, they tend not to take it very seriously. Last but not least, typical labs only service customers that are in close proximity to them so that faster cycle time can be arranged, which means for a global company, they have to use multiple labs in different regions, and very often the information from different labs are not easily shared, and they can make it very, very difficult for the company to understand the performance of the overall oil analysis program on a global scale. One important point that I do not hear people talk a lot about is the oil sample itself. However, it is very important to point this out here because it helps make the case for on-site analysis. A freshly collected sample is the best representation of the oil inside the machine. And this is because a running machine is the best homogenizer to mix particles and waters with the oil. So if an oil is freshly collected and tested right after the collection, the test results and the information obtained have the highest quality because it's the most representative result. As samples sit around or are being transported for days and weeks, particles settles to the bottom and free water separates from oil. So for such samples, labs have to homogenize the sample again in order to recreate the condition of oil when it was inside the machine. So this process introduces variables and errors in the test results. And this is one of the biggest advantages of on-site analysis that was not really mentioned a lot. It is very easy to jump to the conclusion that to resolve the limitations of offset laboratory service, one could just start up a laboratory on site. Unfortunately, it is not the solution. It will certainly improve the cycle time by eliminating the shipping step and therefore help the maintenance team make faster decisions. However, it's only eliminated or reduced one step out of a very complicated process. So other limitations stay the same. So overall process is still complicated with many people involved, and the information still travels from maintenance team's CMMS system to paper to laboratory's LIMS software, and there's still going to be a lack of information or performance dashboard that management can rely on. So, and in addition, the cost of setting up a full-site laboratory on site is very difficult to justify, especially for a typical industrial manufacturer site or power plant where they only process around 1,000 samples per year. The cost of capital, IT, facility can easily cost from $300,000 to $1 million. It depends on the size of the lab. And new staff are needed for receiving, testing, diagnostics, IT, equipment upkeep and calibration, management, and environmental and safety. This is in addition to the knowledge and meeting the regulatory compliance requirements, such as recycle, hazard material handling, and storage. So there's a large hidden cost of running a lab that prevents it from being implemented on vast majority of the industrial sites. So the new demand of Industry 4.0 and the limitations of traditional practice call for a simpler and a holistic approach to oil analysis. Oil analysis need to be a tool in the maintenance team's tool bag instead of a lengthy and complicated process they have to follow. This new approach has to center around the needs of maintenance crew and provide a simple process to follow from collecting the sample to testing to maintenance actions. And the information of asset condition, oil condition, diagnostics, and recommendations have to stay in one place so that high quality and actionable information can be easily obtained. Also, continuous improvements can be made from the intelligence generated from the feedback from the team about findings, potential savings, so management can have a better view of the effectiveness of the overall program. This need for a new approach drives our development and launch of TruVu 360 Enterprise Fluid Intelligence platform. And I would like to take this opportunity to share more details in this part of the presentation. The TruVu 360 Enterprise Fluid Intelligence platform is a tool developed from ground up for maintenance and reliability team to be more productive. It has two components. a web-based software platform to manage the process and the information flow called TruVu 360 Enterprise Cloud Software, and a test system that performs comprehensive oil analysis test suite with our MiniLab series hardware and TruVu 360 device console software. The TruVu 360 Enterprise Fluid Intelligence platform provides lab quality data on site without a traditional lab. This provides high quality and actionable information, including the trending of historical results, diagnostics, recommendations, and maintenance actions. On top of that, a company performance dashboard is also visible to the management team. It is very easy to use without deep knowledge and training. It takes only 5 to 15 minutes to get a complete lab report with automatic rules engines to diagnose the results and recommend maintenance actions. Here are some more details of the two components of the TruVu 360 platform. The TruVu 360 Enterprise Cloud software manages the on-site oil analysis process from scheduled sample collection to testing to diagnostics and recommendations to feedbacks from maintenance actions and to data archive. You can see this. This is much simpler process than the off-site laboratory approach, and it only involves the maintenance team. The information passed along each process step, and it is generated there and flow through the process nicely. The testing step involves the physically testing the samples on the MiniLab oil analysis system. And there is a companion software called TruVu 360 Device Console, or TDC. Its interface with the cloud-based software and controls the hardware to gather raw test data. Now let's look further into details of the two components. First, let's look at the TruVu 360 Enterprise Cloud software. The TruVu 360 Enterprise Cloud software is a web browser-based software. So with the internet connection, users can get access to the software from virtually any computer or mobile devices like tablets, cell phones. The software itself can be installed on a local computer or in a company central server within the firewall or hosted in a public cloud. It supports three types of users. An enterprise user has the highest level of access. He or she can view and manage assets and data from multiple site locations and view the aggregated company dashboard. A site user, however, can only access to a single site and can be even further restricted to certain locations or assets within the site. Site users are typically the ones that manage the whole process and performing the testing or diagnostic and recommendations. A site reader is granted with single site access that can read information only, so there's no write permission. The main user interface of the TruVu 360 Enterprise Cloud is very simple to understand. So what you see here is the main UI when you log into the software. On the left-hand side is the asset tree structure for the site with a simple toolbar on the top so that people can manage the asset tree. You can add an asset, delete it, copy, paste, or edit it. The asset tree structure is based on location, assets, components, sampling points, so it's very logical. On the top right corner, you can see the navigation bar. You can use it to navigate between main page and different setting pages. At the right-hand side, the majority of the real estate is the viewing area. So the viewing area will actually change when users navigate through the different levels in the asset tree. And here you can see the information of that location or asset, a company dashboard based on the information below that level, and an area that user can use to manage the whole oil analysis process. So we'll talk about that in details later. So further on to the main software user interface, if a user navigates to the sampling point level, then user can be prompt to this interface where the last sample information, the trending chart, and all the historical data can be presented in this one view. On top of that, you can see there's right the orange bar, and that's the limit table that is assigned to this asset, to this component. And when you expand that, user can see all the limits, alarm limits that's assigned to the component, and one can edit it if the alarm limit is not accurate or need to be modified. One of the key features of the cloud platform is that it has a built-in process step. It guides user through a much simplified oil analysis process. It uses the combination of sample list in each process step and a set of action buttons to help user accomplish this task. So one can complete the process step and then move the samples to the next step. Here you can see the process steps are really based on some common sense, and it's very simple. So they are schedule, oil collection, testing, diagnostics, and then feedbacks from maintenance actions, and then archive the data so that it show up in the historical trend. Samples are labeled by unique sample ID throughout the process, and it will only show up in this current process step until the task is completed, and then it will automatically flow to the next step. In the next few slides, I will show you each step in a little bit more detail. The oil analysis process starts from the schedule step. This is where a sample is either on a maintenance schedule to be collected, or can be collected on the fly, or for retesting or quick inspection. Within this step, once a sample is scheduled, a unique sample ID is generated. A label can then be printed on a label printer and put it on the sampling bottle so that the information will stay during the testing process. At the sampling time, machine operating hours, mileage or mileage, the oil running hours, there's some maintenance actions like oil change and filter change. These pieces of information can be input there to track the real situation. Once the sample is collected and accepted in the schedule step, the oil sample will then flow to the untested area. All samples in the untested area are waiting to be recognized by the operator, who will physically perform the test using the MiniLab hardware and the TruVu device console, TruVu 360 device console software. So the TruVu 360 device console is a companion software that is installed and run on a local PC that is connected to the oil analysis instrument via USB connections. So we will discuss more details about the TDC later in the presentation. But for the purpose of this discussion here, it's just you need to know that it will collect the untested sample list from the cloud, and then the user can control the hardware to gather raw data from oil analysis and then upload the results into TruVu 360, the enterprise cloud. Once the data is uploaded, the sample is then through a automatic diagnostic process moved to the next step and being diagnosed. Talking about diagnostics, a typical oil analysis report actually contains many parameters because it covers many aspects of oil condition, machine condition, and contamination. For an untrained eye, understanding all the parameters, what they mean, could be a very overwhelming task, and that really requires long training time. This is actually one of the frequently cited reasons why people try to stay away from doing oil analysis themselves. We took a different approach here. Instead of focusing on the parameters themselves, we use a tri-vector chart that in the back end, we group all the oil parameters into machine wear, oil condition, and contamination, these three categories. And alarm limits are set accordingly. So when a user look at the report, they can immediately see from the tri-vector chart what is in alarm, whether it is the contamination or is wear or is the oil condition. So this significantly simplifies the language used in diagnostics and makes it easy for reliability engineers to really communicate the findings from oil analysis report without much training. Another commonly cited barrier preventing people from implementing on-site oil analysis is the lack of expertise. One of the frequently asked questions is how we interpret the data into meaningful and actionable information. In TruVu 360 Enterprise Cloud Platform, we implement a rule engine that helps preview the results and perform a very simple diagnostics automatically. Then user can review the statements and modify it as needed. This two-step process simplifies the overall diagnostics, but also ensure the accuracy of the statements. Once the report is finalized, it can be released and users can be notified. What's unique about this approach is that all the alarm limits, the diagnostic and recommendation statements, they are open to the end users and they can easily be modified to make it more accurate to reflect the real life situation. So in a sense, is very adaptive. The more user use it, the more user added and refine the statements over time, the more accurate it becomes, and it becomes more useful for the automatic diagnostics and recommendation. And after the diagnostic and recommendation, and after the reports are released and users are notified, then what? And this is actually, there's a gap in the previous oil analysis process. Maintenance actions carried out according to the recommendations. Findings from oil analysis accurate? Are there potential savings being recognized from the analysis here? These are feedbacks that's commonly missing from an oil analysis program. And this is because really there's no simple platform to capture this kind of information. The TruVu 360 Enterprise Cloud software closed this gap by introducing one additional step after the diagnostics. When the report is released, sample will stay in the release area and wait for feedbacks from maintenance crew on the maintenance actions, the findings, the potential savings. These pieces of information will then be aggregated and displayed in the performance dashboard for future improvements. Okay, so this pretty much sums up the main functionalities of TruVu 360 Enterprise Cloud Software. One thing I would like to point out is that bundled within the software is a library of factory-supplied reference oils, asset components, and their corresponding alarm limits. User can use them as templates to quickly build up an asset and limit structure at the startup time. This will simplify the startup process. As you can imagine, a typical startup will include setting up the user's permissions, email notification services, site asset structure with the right oil and alarm limits, and build up the sample collection schedule. Now, let's look at the second component of the TruVu 360 Enterprise Fluid Intelligence Platform, the hardware and the TruVu 360 Device Console software. The objective of using the TruVu 360 oil analysis system is to have lab quality data on site without the hassle and the complexity of running a traditional lab. This actually involves our MiniLab series hardware platform. Here are some quick highlights of the MiniLab comparing to a traditional lab. First of all, it only takes a small tabletop space and does not really need a dedicated lab space. The table can be in any office environment. There's no need for special facility requirements. The cost of investing a mini lab is only a fraction of that of a full-size lab, and because of the optimized workflow, it only takes 5 to 15 minutes to complete one sample. This is very beneficial for users that only test a few samples a day. All they need is 30 minutes to an hour of their time every day to perform the oil analysis, and then they can move on to other tasks. So there's no additional hiring. The startup and training only takes typically less than a week, and is only overall use small amount of oil and solvent, so there is not much waste generated from testing. The MiniLab series hardware platform contains up to 6 pieces of hardware performing different aspects of testing. And depending on the situation, only a subset of the 6 hardware is needed. The 6 instruments are for elemental analysis, particle analysis, infrared analysis, viscosity, fuel dilution, and total ferrous measurement. Each test is in compliance with an ASTM standard and only takes a small amount of oil. So, with the exception of particle analysis, there are really no solvents needed or chemical used for these tests. And very low amounts of waste are generated from all the instruments. These tests can be performed in parallel, and that is how we can achieve this 5 to 15 minutes test time. The instruments are controlled by a piece of software that is installed locally on a PC and is connected to the instruments via USB connections. The software is called TruVu 360 Device Console, or TDC for abbreviation, and is companion software with the TruVu 360 Cloud. There are 2 modes of the software. For users with the TruVu 360 license, the TDC is operated in online mode. In this mode, user can log into TDC with their TruVu 360 username and get access to their asset information and the untested sample list without opening the enterprise cloud software separately. After the test, the results can be uploaded to the cloud, and rules engine will automatically be applied for pre-diagnostics based on the alarm limits. For people without the TruVu 360 license, the TDC can also be operated in a standalone mode. We call this offline mode. In this mode, the results will be saved locally on the computer hard drive as a file, either an XML file or CSV file, and can be imported into any other third-party LIMS software. As you can see here, the main interface of the TDC is very simple. So to the left of the window is the instrument control panel. It has instruments that shows the connectivity and the error message box. It will change according to the actual available hardware in the system. To the right of the window, you can see the raw results. On the top of this the toolbar, to the top left, there is a drop-down list of the test suite. And also you can see the sample list drop down to the right. Test suite is a very simple way of grouping different kind of tests based on the component type. For example, an engine oil sample will need different test suite than a gearbox because there's no fuel dilution in the gear, and there's a particle count performed on the gear oil. The sample list is directly downloaded from the TruVu 360 Cloud based on the user login, and once the sample is selected from the list, the corresponding area asset information will be displayed on the top of the window. The Play All button at the center of the panel will initiate all the tests simultaneously. And after the test, the results can be uploaded to the cloud by clicking the Upload button. And then after the pre-diagnostics by the rules engine, the corresponding trivector chart will be displayed on this interface for the sample we just run. And the trivector chart is shown on the top right corner of the window. So the whole process is very seamlessly integrated, and it helps user to quickly assess the sample results. To make things even simpler, the TDC includes a guided testing feature that will give user a step-by-step guidance of sample preparation and introduction. In each step, a very short video, typically less than 5 seconds, is automatically played to show user how to perform a certain task. So for any task that actually is time sensitive, like requires a certain time of preparation, a timer will be displayed to help user to better control the timing. This feature is designed to help user to maintain their training after the initial startup training and remind infrequent users how to perform the test consistently so that the high quality data can be generated all the time. This pretty much explains all the key features of the TDC, and I hope you can get the impression that it's very simple to use, and especially for novel users. Consistency and the simplicity are what helps to generate lab quality data. So with the overview of the whole TruVu 360 platform and its components, let's talk about what it really means for global companies. And really, I think in one sentence to summarize it, the TruVu 360 platform really delivers the best practice for oil analysis for the global enterprise, and they can roll these practices out very, very quickly. And let's see why. Well, it's relatively easy to optimize a local oil analysis practice within a plant. It's actually pretty hard to standardize it across a global plants. There are three main challenges. First of all, if using offsite oil analysis lab, on a global scale, companies have to choose different labs locally to optimize the cycle time and cost. Um, it is very common that among different labs and plants, there will be very large variation in sample process time. Some lab is quicker, some lab is slower. This makes it very, very difficult to standardize the workflow globally. With the TruVu 360 platform, though, this challenge can be addressed by the standard process defined in the software already. The second challenge is it's very difficult to leverage learnings and best practices globally. This is because, again, using different local labs, most likely the assets, the sample histories are stored in a different software from different locations, and it's near impossible to consolidate them all and maintain them well. Also, differences in local laboratory expertise and experiences might create different recommendations on the same or similar test result. Without very close feedback loop, there's very no easy way to tell which one is more accurate. And this challenge is very difficult to address with the current oil analysis practice. The TruVu 360 platform addresses, though, because with one software for all global sites, one can access to the same rules engine, to the same amount of information and the same feedbacks, and they can improve and refine the rules engine over time so the whole company can benefit from it around the globe. The third challenge is that there is generally lack of visibility of oil analysis on both local and global scale. and just because that intelligence is very difficult to obtain. It's difficult to see how effective the oil analysis program is. And again, with the company dashboard on different levels, TruVu 360 platform can address this challenge very easily. This is a snapshot of the TruVu 360 enterprise cloud software, and you can see the dashboard is right in the center of the main page, and with the prime real estate. So this is to highlight the importance of the performance dashboard to the end users. The contents of the dashboard, however, is changed according to different levels user is at on the asset tree, and the information that is actually usually hard to get, like total repair savings, the total oil consumptions, they are displayed on the dashboard to remind user the effectiveness of the oil analysis program. These informations are obtained from the feedback loop in the last process step that's defined in the software. One thing to point out here is that the dashboard is a feature that we plan to update frequently over time based on the feedback from the user. So always the most useful and insightful information is displayed here. Well, I hope at this point you can see that the TruVu 360 platform can really help companies standardize their oil analysis practice and utilize it to improve their predictive maintenance practice. So with the installation on the central server or in a public cloud, company can roll out the platform very quickly across physical boundaries and expect consistency and quality outcomes. One thing I would like to point out here is that within the TruVu 360 framework, any local installs of MiniLab oil analysis hardware can be easily turned into a regional lab to support sister plants nearby, while companies still leveraging the integration of process information and intelligence. This helps people to roll out the on-site oil analysis program in phases so that they can maximize return on capital investment. One side benefit of on-site oil analysis program is once the program is in place, users typically quickly find out they can test more assets with more frequencies and gain much more benefits from oil analysis than previously planned. This is because with cost and time constraints, companies typically only send samples from the most critical assets at a minimum frequency to offsite laboratories. We have seen cases again and again that users with on-site oil analysis, they can increase their total number of samples by as much as 10x within a year. So users now have a very powerful tool they can use for, inspecting their oils on delivery and infrequent, irregular test samples and other circumstances. In summary, by leveraging TruVu 360 platform, companies can achieve program success on a global scale very quickly. With the ease of use, simple process, lab quality data, quick and insightful intelligence, closed loop feedbacks, and enterprise dashboard for global visibility, one can more than ever take advantage of the full power of on-site oil analysis and stay competitive and profitable in the Industrial 4.0 era by increasing asset availability, reliability, and ROI, reducing operating expense, and enhancing productivity. This concludes my presentation. Thank you very much for your attention.
Okay, Mr. Zhao, thanks very much for that great presentation. Okay, Yugong, here's your first question. Why was on-site analysis not as popular as off-site before?
I think to answer this question, there might be two things to talk about. One is on the product side. For a long time, to implement on-site oil analysis, there's really two approaches people can use. One is to build a full-size oil analysis laboratory on site. This is good for sites that has a lot of equipment and can justify the cost of implementing the laboratory because they can have tens of thousands of samples run per year, and a lot of times they also support other plants within the same organization as well. The second approach people use is to use on-site oil analysis screening devices, and a lot of tools on the market. They can tell the some information about oil analysis by measuring the oil, but they don't always match exactly to lab quality data and information. So it's difficult to trend. This has changed over the last few years with some of the new products introduced on the market from Spectral Scientific. But then it's get to the education piece. People are still not fully aware of such solution, and they still might have the perception that if they need a lab quality system on site, they still have to go through the hustle of implementing a full-size oil analysis lab.
Okay, thank you for that answer. Here's another question. What is the typical ROI investing on site analysis?
The ROI of an on-site oil analysis program varies from industry to industry and from company to company. Also, it really depends on past practices as well. For those who have not done oil analysis program before, there are many case studies showing that within a few months to a year, the investment is paid back because they have immediately identified potential failures or save expensive repairs. We call them low-hanging fruit opportunities that can quickly justify the investment of on-site oil analysis program. For those who have already invested in an off-site oil analysis program, there are some benefits taken from the existing program. So in those cases, on-site oil analysis program will significantly improve the speed and quality of the information, and people can integrate that into their workflow. And we have heard cases that within 1 to 3 years, the investment was paid back because of the improvement they have over the existing program.
And thanks again, Mr. Zhao, for that answer. Here's another question for you. What are the key decision factors to consider before investing on-site oil analysis?
There are several key factors to consider when deciding to invest on-site oil analysis. The first one is the total number of critical and important oil lubricated assets that need to be monitored on a regular basis. A simple rule of thumb, if collectively the number of samples exceed a few hundred samples per month, there is a case to be made to have on-site oil analysis program, and we can justify the return on investment. The second factor is the cost of downtime. For critical assets, that the cost of downtime is very high, or the lead time of some critical components are long. Having an on-site oil analysis will help predict the failure and schedule the maintenance in advance. The third factor to consider is the cost of oil consumption. For example, for a fleet with many mobile equipment, like the transportation, construction, or mining fleet, on-site oil analysis can significantly help save costs on oil by extending the oil drain interval, and therefore can justify an oil analysis program. So there are some other factors to consider, but these are the top ones.
And thank you very much. Here's another question that came in. What is the maximum throughput of the MiniLab system?
The throughput of a MiniLab system depends on the oil type. For an engine oil, it takes roughly around 5 minutes per sample. In industrial fluids like turbine oil, gear oil, it takes from 5 to 10 minutes per sample. The variation is from viscosity measurement. Some oils are having very high viscosities, like 680 standard stock for gear oil. That takes a longer time to finish the viscosity measurement. We have seen, however, customers testing over 100 samples per day using MiniLab system on a mining site.
Okay, Yugong, thanks very much for that answer. Here's another question. Why is closing the gap between maintenance action and recommended actions in the report so important?
This is because without the feedback from maintenance team about a recommended action from oil analysis report, the recommendation is just a recommendation. And there's no visibility of if this is true or false, or if there's any additional findings that make the future recommendation more accurate. Oil analysis diagnostics are based on a set of limits that is applied to the testing result. In the early stage of oil analysis implementation, the alarm limits need to be fine-tuned over time so that they can be fit into each asset. They have its own personality. Some assets runs just differently from the other, even though they are from the same manufacturer and same model. This fine-tuning of the limit is based on the feedbacks from the maintenance team on their findings of the maintenance actions. So just like any continuous improvement process, this closed loop feedback is very important.
Okay, here's another question. What are the common issues during the sample collection process?
Sample collection is a very important step of oil analysis program because it's the starting point. A high quality and representative sample ensures the quality of test results and recommendations. There are published recommendations on sample collection practices from many organizations and laboratories. Here are some common issues one can encounter during the collection process. Like sample can be contaminated during collection, or people use dirty bottles. The label was wrong or completely missing, or the label are not readable because it got covered by oils, or the handwriting is not clear, or there's a common issue of the cap on the bottle was not tight enough. So during transportation, the sample will leak out and potentially get into another bottle. So there might be some cross-contamination going on during shipping. So those are common issues where the sample or the information of the sample are not good, and therefore those samples are completely useless for oil analysis.
Okay, great. Thank you. We've got time for another question. Why is it sometimes the recommendation is to retest?
This is because of the potential errors in sample collection process. Before a major maintenance action is recommended, one need to make sure the sample has high quality and the test results really represent the real life situation. So retest is a very common recommendation from off-site laboratories because no one wants a false alarm just because of a bad sample. For on-site oil analysis program, though, retest is much simpler and easier to do, and also will be much less frequent, just because many of the sources of errors, like the ones I mentioned in the last answer, are completely eliminated. So the chances of a bad sample is much less.
Okay, and with that, we're going to have to wrap things up right there. Yugong Zhao, thank you so much for taking the time to be here with all of us today. And we'd like to say thank you to all of our audience members for being part of this webinar event. Take care and have yourselves a great day.